All right, so it's 6/8/16. Here's some Calc 2, and we're going to be looking at some partial fractions today. So here I've got a warm-up problem, just decomposing this fraction with the numerator being 3x plus 11 and the denominator being x squared minus x minus 6. So go ahead and take a little bit, decompose the first problem, and go ahead and throw it in the chat when you have a final answer. You can send it to everyone. You can send it privately to just me. Also, again, if you guys have any questions, you can always unmute yourselves and speak, or you can use the group chat. All right, awesome. So I'm already starting to get some answers. Maybe some people got started on when I came online and posted it. So don't worry too much if you just got on and still working on the problem. Give you guys just a little bit longer. And no worries if you don't finish by the time I start. You can always work with me and we can check your answers at the end. How's everyone doing? You guys doing all right? How are your opinions on how the online recitations and lectures are? It's probably a little bit weirder. Certainly is for me. Speaking for an hour to myself in a room, it's a little peculiar. But hope it helps you guys. All right. So let's go ahead and get started on decomposing our problem here. So again, we have 3x plus 11 all over x squared minus x minus 6. So the first thing we're going to do is we're going to factor the bottom here. So the numerator is going to stay the same. We got 3x plus 11. But on the denominator, what we're going to do is this actually factors into x minus 3 and x plus 2. Right? So now that we have this factorization, what we can do is we can write it in a form, some constant a that we've got here, a over the first factor that we have, this x minus 3. And then we're going to have our second factor here, x plus 2. Okay? Awesome. So how do we solve for these a's and b's? Well, what we do is we have this denominator on this side right here in green, and now we've got these two, right? So what we're going to do is we're going to multiply the the denominator of the left-hand side over, okay? And what that results in is we're going to have this 3x plus 11 without its denominator since we're multiplying it over. And you'll notice that the x minus 3 factor will cancel, right? So we'll have an x plus 2 times a. And then on this one, the x plus 2 factor will cancel. So we'll actually have the other one. We'll have x minus 3b. Okay? So what we're going to do now is we're going to collect all of the terms that we have for x's, powers of x. Okay? So in this case, the highest power we have is 1. So it's not too bad. So what we're going to do is collect the x terms, right? If you look, we'll have x plus b times x. So that's our grouping of x terms, right? Because back over, we'll have our a times this x on the first term, and then the second term we'll have b times that x. So we'll have this a plus b times x. Then the next term here is the constant terms that are left over, which in this case will be 2a minus 3b. All right, so now where do we go from here? Well, we're going to go ahead and look at the coefficients. So we've got this 3 here, and we have this a plus b here on these x's. These have to be equal. Same thing goes for this 11 right here, and our constant terms, 2a minus 3b. Those things have to be equal, right? So that gives us two equations. We have 3 is equal to a plus b, and we also have 11 equals 2a minus 3b. So these are our two equations, and we have two unknowns. So we can actually solve for a's and b's here. So I'm going to look at the first one, this 3 equals a plus b. I'm going to rearrange it and solve for a. So a is equal to 3 minus b. Right? So I'm going to use this now and sub it in for the guy on the right. So I'll have 11 equals 2 times our 3 minus b minus 3b. And this guy is just 6 minus 5b. So if I move the 6 over, I'm going to get a 5 equals negative 5b. And that means that I have b is equal to negative 1. Now, since I have b equals to negative 1, I can go ahead and solve for what a is. I can go back over, and that means that a is equal to 4. All right, so now I have my a's and b's, and I can go ahead and finally write what my decomposition is. So I have 3x plus 11 over x squared minus x minus 6. And this is equal to our a over x minus 3, but a in this case is 4. So we have this first term. So now we have, I shouldn't have an addition there. We have a subtraction because b is negative. 1 over x plus 2. All right, and then this is our final factorization. So that's kind of just like a warm-up of decomposing these fractions in terms, and what we call it is partial fractions. And why is this helpful? Well, it helps us integrate. If you look at the first thing that we have, the thing that we were supposed to decompose, that guy is messy. I don't want to take an integral of that. That's absurd. But what we can do is decompose this fraction in terms of what we found and then easily integrate. So the things that we found or decompose them into are fairly easy to integrate. meaning that the problem itself should be easy to integrate. We just have to know this trick. So what really is this trick? So how it works is, let's assume that we've got this polynomial p, and it's all over another polynomial q. So we've got p of x and q of x. And what I'm going to do is, so we're going to write out what p of x might be. It might look something like a sub n x to the n plus a sub n minus 1 to the power, and then x to the power of n minus 1 plus, and then we're going to have some other terms here, and then eventually we're going to get to a 1x plus a naught. So it's a polynomial of degree n, and the a's a sub n or a sub n minus 1, those are just coefficients, right? So now what we're going to do is we're going to write q. Now, the thing with q is it's not just any old polynomial, but we can actually factor it. So I'm going to write it as its factors, right? So the first factor here is b1x plus c1, and then of course the next one will be b2x plus c2, and then this is going to be multiplied a few times, and then eventually we're going to have this bkx plus ck. So in order to use partial fractions, we have to make sure that, so the power of p is n, and the power of q is k, right? Because if you multiply all these factors, you'll have the highest one will be a factor of k, or x to the k. So we have to know that k is greater than n. Otherwise, we have to do a long division to get it into this form, right? Now, if we do have k greater than n, we can decompose it. So let's assume that we've got k greater than n. So what I can do is change this into something like the first factor that we've got here in the denominator. And you'll probably see the pattern here. And then we'll add this a few times, a few extra terms. And of course, the last one is going to be a sub k, p sub k, x plus c sub k. Right? Now, where do we go from here? What we can do is we can multiply this q of x over, and all the remaining terms will, all right, so let me back up. If we have this q of x and we multiply it over, all the denominators will cancel with at least one of those terms, right? So if you look back up at the other one, change colors here for the highlighter. If we've got this thing and we're multiplying it over, the first term won't have it because it will cancel, but you'll have all the other ones left over, right? Same goes for the second one here. If I've got this, on the second term, those things will cancel, and I'll have all the other terms on the numerator, right? So now I don't have any denominators anymore. Everything's in the numerator on both sides. What I'm going to do is I'm going to multiply them out and collect the powers of x. So we'll have a polynomial on both sides. So what does that mean? Well, the coefficients must be equal to one another, right? If the polynomials are equal. So then I'll have some kind of function. So my a sub n's from p of x will be some kind of function of all of the b's, the c's, and the a's. right? So now what I can do is make a system of equations of A, capital A, and solve for them, kind of like we did for decomposing number 1. So to go a little bit further, if Q had this really nice form here, where there were separate factors, that's not always true. So let's go ahead and go to the next page and talk about what happens if it's not of that form. So let's make a little chart here. Factor and denominator. So we have a factor in our denominator. And then on this side, we're going to have our term in partial fractions. Okay. So the first one is the one that you guys are used to seeing, kind of how we did it before, is if we can get this factor in the denominator that's, let me go to the next one, this ax plus b, right? Well, if we have this ax plus b, then the term in the partial fraction is this capital A over our original ax plus b. Right? So not too bad. So now when we go over, let's say we have a bit of the form x plus b. So there's multiples, right? So the power of k. I've got some number of these things in the denominator. It becomes a little bit trickier then. So what I'm going to do instead is have this a sub 1 here, ax plus b. Notice it doesn't have a power. But now I'm going to add this a2 over ax plus b squared. I'm going to keep adding until I get to that power. Right? So depending on what k I have over here, I'm going to go to that power in the denominator. I'm going to add that many things. Right? And we'll do something, we'll do a practice example of this later. Sorry. So now, what if we have something that's not just like an ax plus b, but rather an ax squared plus bx plus c. That's the factor in our denominator. Well, it's not as simple as what we had as in the first one, but it's not too bad either. So we've got this ax b in the numerator, and then we have our original factor on the bottom. So notice that now it has an x in the numerator. Just keep that in mind. It has an ax plus b. So it has two constants in it to solve for. And we'll see another example of that later. We'll actually have a combination of these two. And you could probably guess, well, what if I've got the above case but to a power of k? Well, it's just like how you went from the first case to the second case, but now we're going from the third case to the fourth case. So we're going to have an a1x plus b, or capital B, 1 all over our original guy to the first power. And then we're going to keep adding until we get to the kth power. right? So these k's, again, are matching up, right? And we're adding that many until we get there. All right, so now let's go ahead and look at another example. So we're actually going to use this to integrate something now. This one's not so bad, so don't worry about it. The next one after that is a little bit more difficult. So number 3 is a little bit harder. Maybe we should start on a new page here. Keep this guy open just in case we make some more notes. So we've got number 2, and I want you guys to try to see if you can integrate this guy here. So in the numerator, we've got x squared plus 4, and then in the denominator, we have 3x cubed plus 4x squared minus 4x. So I want you guys to go ahead and see if you can decompose it. Let's take this in steps. So go ahead and try to see if you can decompose the fraction that's inside the integral. And then give me an answer. You can type it into the chat. So I know where you guys are at. And then we'll integrate it once we decompose it. The integration's not so bad. All right, let's go ahead and start decomposing this fraction. So what I'm going to do is set this integral equal to I for later. So let's go ahead and look at the fraction that we've got inside. We've got this x squared plus 4, and this actually, the denominator factors into x plus 2, and 3x minus 2. Right? The x one's kind of easy. They all have factors of x. You pull that out, and then all you have is a quadratic. So this is going to be, if we go back to our rules here, they all are of this form here, right? So we have a over x. Oops, we'll have the, there we go. Okay. And then we have b over x plus 2. And then we have c over 3x minus 2. So we're going to go ahead and multiply the denominator over. So we have x squared plus 4 is equal to 3x minus 2 on our a term, then on our b term, and then our c term. Right. So I'm going to rearrange this right-hand side and put it in terms of the powers of x. So we can see that on this first term, we're going to have this 3x squared plus 4 minus 4a. Next term here is 3x squared minus 2x b. And then this last term is x squared plus 2xc. So we can kind of see the grouping of the powers of x here in this line. For the x squareds, we can see that the first term gives us a 3a, the next one gives us a 3b, and then we only get one c from that last one. That's x squared. Now the coefficients for x are 4a minus 2b plus 2c. And then our constant term is just minus 4a. So now that gives us three equations for our system, right? So the first one here is this 1 that we got out there, and it's this guy. Now we don't have an x term in this on the left-hand side, right? There's no x term. But the coefficient there is 0. So this guy is equal to 0. And then we have the 4 left over here, and that's equal to our -4 right there. Should include the here with it. Okay, so writing it out, we have 1 equal to 3a plus 3b plus c. And our next guy here is 0, is 4a minus 2b plus 2c. And then the last one, luckily for us, it's pretty easy. 4 equals -4a. So right off the bat, we can find out what a is. A is just -1. So I'm going to go back and look at the first equation here now that we know that a is -1. So we've got 1 is equal to this -3 plus 3b plus c. Rearranging this guy, we have 4 minus 3b is equal to c. I'm going to take this equation here, and we're going to move it over and use it for our second equation. Okay, that means we have 0 is equal to -4, right? Because we still know that a is -1 minus 2b plus 2 times 4 minus 3b. factoring that out, or foiling it out, and then rearranging, we've got -4 is equal to -8b, right? Which means b is equal to 1/2. And if b is equal to 1/2, we can go ahead and use it back in this equation. That means c is equal to 5/2, right? Let's back up. So it's 8/2 minus 3/2. So we get 5/2. Yep. Okay. So now we can decompose our fraction here. So now let's go back and look at our integral I. This is equal to the integral -1 over x plus 1 over 2 times our x plus 2, because b was 1/2. And then our c term was 5/2, so we have a 5, and then a 2, 3x minus 2. Don't forget our dx here, and then we're going to make sure to group everything that. And then this is just a pretty easy integral, right? So we've got negative the natural log of the absolute value of x from that first term. That second term, that 1/2 just comes out, and we have the natural log of x plus 2. Right? We did a u substitution for x plus 2. And then this last guy is 5/6 natural log 3x minus 2. And then we can't forget our plus c. The reason that's 5/6 is when you do that u substitution for 3x minus 2, you'll have that 3 left over, and it comes over, and you get another third. So our 5/2 becomes a 5/6. Right? And that just shows us how easy it is to integrate this weird guy that we've got up here. Let's use a highlighter color. So we've got this integral here, and that's pretty messy. But rewriting it as this whole thing here, it's a lot easier because we can treat each term individually, right? So if we're looking at that, so we can integrate each one of those terms individually, and then it becomes a lot easier. All right, do you guys have any questions about this problem? All right. So I'm going to go ahead and move on. So we're going to go to the next problem here. And I'm going to go to the page. One's definitely going to need the space. So number 3, the integral x squared minus 29 x plus 5 So in the denominator here, we have an x minus 4 squared times the quantity x squared plus 3, right? So give me a second to write that down, and then we're going to go look back at our chart that we wrote before. So this first term here, this x minus 4 squared, if we go back to our chart, it resembles this guy, right? With k being 2 now. So we go back to our page over here. We can look at the next guy here. Now it's an x squared plus 3. This resembles this guy, right, with b being 0. Now a being 1 and then c being 3. Right? So go ahead and take some time, set it up. Decomposing it is actually pretty messy. See if you can get the equations, the system of equations that you need to solve. Because as a hint, you're going to have 4 things that you need to solve for. You have A, B, C, and D. Just set it up. See if you can find the equations that you need. All right, so the first step is we're going to just write out what this fraction could look like, right? So the yellow term, this x minus 4 squared, its defactorization looks like a over x minus 4. But now because it's squared, we're going to have this additional term, b over x minus 4 squared. Right? And this is solely from our yellow term in the problem. Now for the purple term, we're going to have a cx plus d all over x squared plus 3. And this is from our purple term. So we have 4 things that we need to solve for. So I'll give you guys a little bit to see if you guys come up with the equations that you'll need to use to solve for this A, B, C, and D. All right. So if we multiply over the denominator, what we're going to get is an x squared minus 29x plus 5 from our numerator. And on the right-hand side, we're going to have this x minus 4, x squared plus 3, or our a, plus this x squared plus 3 for b. And then, yep, so we have an x minus 4 squared or our cx plus d. Now rearranging this guy, so you have to FOIL those out and then collect the terms for the highest power you'll have is x cubed. And if we do this, we'll get a plus c for the x cubed power. Now, for the x squared power, we have negative 4a plus b minus 8c plus d. And then for the linear term, just the x, we have 3a plus 16c minus 8d for x. And then our constant term, so I'm just going to go in the next line here, minus 12a plus 3b plus 16d. Right? So we have our equations that we can now look at. So we've got this coefficient here that relates to, back up. So there's actually no x cubed, right? So I should go ahead and back up. So this is kind of like if we added a 0 times this x cubed here, right? So this 0 is what we're relating to this. Now the one that's in front of this x squared is related to this guy here. Then this negative 29 is related to this guy. And then our plus 5 equals to this. So our equations that we can list now are a plus c equal to 0, negative 4a plus b minus 8c plus d is equal to 1. This 3a plus 16c minus 8d is equal to negative 29. And then a constant term is negative 12a plus 3b plus 16d is equal to 5. So this can get pretty messy. So the way that I would go ahead and tackle this, we're not going to waste too much time on solving this. I'm just going to go ahead and tell you guys what I got. So what I did was I solved for this either A or C, plug those in, and then solve for one of the other variables, and then you're down to two equations, and then they all kind of just crumble like dominoes. Once you find one of them, then they all start kind of going down, right? So what does this actually give us? I'm just going to go ahead and tell you. A is 1. B is -5. C equals to -1. And D is equal to 2. So now with this, go ahead and see if you can integrate what we have up here. Let's set this equal to I. So find out what I is. I've given you guys the defactorization. So what's left over is just stuff that we've learned before, just integrating those individual terms. As for having a question like this on like a test, I don't think this is a good test question just because of the 4 variables that you'll have to solve for, and the equations themselves are pretty messy. There could be a problem that has 4 things that you need to solve for, but the A, B, C, and D are relatively easy. Maybe the first equation wasn't A plus C equals 0. We just had A equals 0, right? And then we can get rid of that term completely, right? And then all we need to do is solve for the other 3, and those might be simple things. So another thing that I've typically seen on tests is making sure that you know how to decompose. I think that's the biggest leap that you have to make when doing partial fraction integration, is given your factors on your denominator, what are you supposed to decompose it as? So the second line that we've got there, let me go ahead and just, so what's in that box? Knowing how to do that is probably the most important, right? Because then it's just tedious algebra, right? Just rearranging. And of course, getting the final answer is always really nice. But just make sure that you know how to do that second line there. So going back to our other page here. Just, I don't know if this is in the book, but I'll upload this recording later, or if you have written it already, keep that, know it. These are very important. So we're going to go ahead and go back to the page now. All right, let's go ahead and write what our integral is actually equal to. So our I here is equal to, I'm going to do this, well, we can make an extra step. So writing this out, we've got all we have to do is plug in our A, B, C, and D into that squared portion, and then making sure that we have our integral. So actually, I'm going to go on the next line here. this is equal to, and break up our integrals to each term. All right, so we have these 4 integrals now. Notice that I split up the fraction here into these 2 separate integrals, right? Okay, so let's go ahead and integrate now. So this first term, we do a classic U substitution for x minus 4. We're going to get the natural log of x minus 4. Right? Now this 5 comes out, and then this is just easy polynomial, right? We have 5 over x minus 4. Right? You can do a U substitution on that one as well. For this one, do another U substitution with x squared plus 3, and you'll get to minus 1/2 the natural log of absolute value of x squared plus 3. And then this last guy here, if it looks familiar at all, it's the arctangent integral, right? And I think that's listed back in chapter 5 or in the back of your book. And it comes out to being 2 over radical 3 arctangent of x over radical 3 plus c. Let's just check here. We've got all our signs right. There's a question about this guy here was a positive. Well, b was -5. So, wait, then we have the power. Yeah, so it would actually, you're right. This would change sign. That would be a plus. Good catch. If you guys have any questions about this one, I know we kind of skipped some of the steps, especially when we just found out what these guys are. Just giving that to you guys, but I wouldn't expect you guys to solve for those with these 4 equations. That gets really messy. That would just take way too much time. And just remember that you have formula sheets, and I think those are posted on the website. They'll probably include integrals like that. How dark can I make it? Pretty dark. Okay. All right. If you guys don't have any final questions, I guess we can call it and stop recording. We've got a little bit of time before we stop the conference call. I hope you guys enjoyed the online experience of this recitation. You guys are doing all right. So there's about 40 people in this class, and I would say typically 7 people come to these recitations. So those of you that are coming regularly, great job. This is exactly what the course is supposed to be like. It's self-motivated. So those of you that are here, you're doing great. Just keep up the good work. And I guess that's all I really have to say for tonight. So the next time I will see you guys is Monday, right? Monday's the next recitation. Don't forget all your quizzes and homeworks. Make sure you check the schedule online. Also, you've got your web assign. Also, those of you that might have gotten an email from Silva concerning your uploads for homeworks, double check your emails, double check the scores and comments, because we do leave comments on your homeworks, and the solutions are up as well. So check those out, see if you can improve, because I've left a few comments on the homework pertaining to like how you should form your writing, not just how you're uploading. All right, so I will see you guys Monday. I'm gonna go ahead and stop the recording.